Okay, so now with the torus, remember, I said fold it up into a cylinder like this, and then if you're going this way. But what did I do with the Mobius strip?
Well, you pointed these arrows in different directions.
Yeah, so that said you got to do a half twist.
Yep.
Okay. So instead of matching them up the same way we did to make the torus, I'm going to make the bottom one on the piece of paper, which could be the side one if I just rotated it, right? There's no real top and bottom. I'm going to make a twist there.
So this is a Mobius strip out of a cylinder.
Right.
Like, how do you even half twist a cylinder?
Right.
Yeah.
But this is a perfectly valid shape. Like, you could understand this shape as a piece of paper, as a two-dimensional piece of paper.
Yeah.
Flip. Flip. Right? Just like it was. So going this way, it's a Mobius strip. Going this way, it's a cylinder.
So, how does that even work? Is that another four-dimensional shape?
Yeah, and I guess I should be careful when I say four-dimensional shape. It's a piece of paper, so it's a two-dimensional shape. It just lives inside of 4 dimensions naturally. So I do have to be careful about that. Since it's a piece of paper and a flat piece of paper, it's a two-dimensional shape. But in order to see it, what it actually looks like, you need to be in 4 dimensions.
Yeah.
So what do you think this one's going to look like? What's going to happen here? How do you twist a cylinder? That's the problem.
Well, you could do the Mobius strip first and then try to roll it into a cylinder.
Ah, awesome idea. Here, bring in one of our Mobius strips. It's over there. Doesn't matter which one. Okay. All right. I guess this would be this way, right?
Yep.
All right. So I got this arrow and this arrow on this side.
Yeah. Give it a twist and then...
Okay. What's the problem now? Identifying these two arrows, these two sides.
Well, like one of them may be here,
Okay.
and then one of them's going to be going in this direction.
All right. There's a much worse problem if you try to do the Mobius strip first. Where are those two sides?
There's only one
It's on the
side.
same side. So it's technically impossible.
Wait, where are they? Show me where this side is on our sheet.
Well,
This side of the paper. Where did it go?
wouldn't it be like here? Roughly? Because you have... But all the
The
sides...
edge. See the edge here of the paper? Let's unfold it like this. So what does this edge correspond to right
Well,
here?
it would correspond to this edge.
Okay. And where does this edge correspond to?
The other edge.
Okay. What happened to those two edges when I made the Mobius strip?
They became...
They became...
one edge?
Well, this is one edge here, and it turns into the other edge.
Okay. So the two edges. What happened to the two
They're
edges?
the same edge.
The Mobius strip only has one edge. So how do I like sort of fold up the Mobius? You think it was weird to try to fold a cylinder this way?
You really can't fold a Mobius strip.
Yeah, it's
up into a
really
cylinder.
tricky to think about what this is. So it's interesting. Yeah, you're right. So you see, you guys have understood these diagrams well enough to know that this is going to be very difficult to understand what happens to this shape. This shape is called the Klein bottle.
Yep.
And the reason why it's so difficult to understand what this shape is in order to fold that cylinder to have one circle having the opposite orientation as the other one, it has to go inside of itself.
So, like, if you pour water into this, it'll just
Stay in there.
stay in there and just come out the bottom.
Yeah, I'm not sure.
It'll leak through
It's
the holes.
tricky. It's tricky. So this is a very interesting shape, and just like you said, it's very hard
To imagine.
to imagine. Okay, so give me one last blank piece of paper. So what's the remaining situation that
double
we can?
Mobius strip.
Yeah, we can make a double. We can make a Mobius strip that way, and a Mobius strip this way. Which again, you could understand this by just saying, "Hey, look, I'm moving this way. I flip upside down. Moving this way, I flip back upside down." Okay, moving this
I
way.
think there's another mirror image of it. So, is it the same? If the arrow is pointing this way and the arrow is pointing that way, is it the same?
Ah, that's the Klein bottle.
Yeah.
Yeah, that's the Klein bottle. Because all I would do is just rotate it like this.
Yeah.
So here I've got this double reverse identification.
How do you make a Mobius strip from a Mobius strip? It's the same.
Right, so before we were saying it's pretty weird to try to think about how to identify the two sides in the same way when they become one. On this shape, I have to identify the two sides in the opposite way, but they've become one. So somehow it's even more weird.
So how do you do that?
Yeah, and this is called a projective plane. That's the name of this. And this one's really hard to visualize. We really need to take a trip to 4 dimensions to see this one. Because every picture I've seen of what this would look like in 3 dimensions, it makes no sense to me. The Klein model, at least, you can sort of understand.
Yeah.
The projective plane I find very difficult to make any sense out of.
Yeah.
But it's actually, the projective plane is a really important shape in math. The Klein model, although important, doesn't come up all that often. The projective plane is something a lot of people study.
Cool.
So there you go. So here's our shape. And it's important, this is an important shape because it helps us get a little bit better understanding of what the actual geometry in a torus looks like.
Yeah.
It's a cool shape though, isn't it?
Yeah.